Good morning. Welcome back. So in the previous class we have studied about how the reflection takes place when the ray is incident on curved surfaces. Okay, so let's just give a quick review of what we have learnt and then let's proceed to the next part of the class. Okay, so now concave mirror. So this is a coated surface and this is the optically polished surface on which now we are going to incident the rays, and this is the concave mirror. And what are the fundamental things that we are supposed to know? This is the pole of the mirror P and yet the center of the curvature. This is the center of the curvature C, and a line which passes through the pole and the center of curvature is principal axis. And we have already discussed that normal drawn to the curved surface always passes through center of curvature. Clear? So this is the principal axis, normal, center of curvature and pole of the mirror. Now today we are going to learn about what is a focal point, where it is located for concave and convex mirrors, and how to locate the focal point and what is the definition of it. Okay, so today's theme is to find focal point. So let me define the focal point first. So when a parallel beam of rays, that means when the rays parallel to the principal axis, or when the rays are coming parallel to the principal axis, upon reflection they seem to converge at a point, and that point is called the focal point. They seem to converge at a point and that point is called the focal point. Which rays we have to consider? A parallel beam of rays. That means a beam where the rays are parallel to each other, and here also parallel to the principal axis we are going to consider. And when they are incident, they are made to incident on the concave mirror, they reflect back and all the reflected rays converge at a point, or all the reflected rays pass through a single point. That single point is called focus or focal point. That single point is called focus or focal point. Now the point here is, from where do we get this source? From where a parallel beam of light emerges out? Let us come to this first. Suppose if there is a bulb. So the light rays come out like this. See, they are not parallel to each other. We want something like the rays are supposed to be like this, parallel to each other. The rays are supposed to be like this, parallel to each other, equidistant between the respective points between any two rays. Okay, so we want this kind of beam. But if you take a source, that means if you switch on a light, or you take any other source like a candle or anything, the light rays emerge like this. We need this one. So from where are we going to get this? To understand this, let us do a small activity. You can do it at your home. Now I am going to show it here on the board. Take a thermocol box. Fix two nails on it parallel to each other like this. Put that box on a table and at a certain distance keep a candle, a glowing candle. Please remember, this has to be done in a dark room. Okay. And then you can see the image of these two pins will be like this. That means the image of the pins can be like as though the pins are getting diverged away from each other, or the nails are getting diverged away from each other. Why is this forming here like this? The image is forming here like this because the rays are coming like this, divergent. Hence the image is. And now slowly you move the candle away from the box along the same straight line again. You move the candle away from the box along the same straight line. Like this. As you are moving away from, you can see that the nails the image of the nails try to tend towards each other, and you can slowly see that a parallel beam of rays falling on it, and thus the image will be like as how the object is. That means here you have taken two nails to be parallel, here also you get the image to be parallel. So what can we conclude from this? So we can conclude that if the source is far away from, like this, then the image formed here is just like how the object is. That means the rays are emerging parallelly. Right? So they are not emerging parallelly here, but as you move away from the source, the rays tend to fall on the object parallel to each other. The rays tend to fall on the object parallel to each other. Okay, so that means we need a source which is very far from the object. Yes, here there is a limitation again. As you are moving away from, that means as you are trying to make the candle move away from the object, you can see that the intensity of the image formed is less. That means intensity of the light rays reduces. So what kind of source we need? We need a source which is very far from the object, as well as the light rays are supposed to be more intense. So we want a very intense source of light, as well as a light source which is very far from the object. In nature we have such a source. You all know it. Yes, sun. So here we are going to perform the experiment using a concave mirror and sun rays. Using concave mirror and sun rays. So take a concave mirror. Keep it in a direction facing sun rays. Take a small piece of paper, okay, small piece of white paper like this. And now, how the rays will be falling on the concave mirror? As per what we have learnt now, the rays fall parallel to the principal axis. Let me take the rays to be like this. I will take one ray there and one ray here. Okay. So I am taking a parallel beam. So the rays are parallel to the principal axis here. So these rays are falling now on the concave mirror. Now the paper you have taken and you are keeping it somewhere here between the P and C or somewhere, and as you see that as you move the paper away from the mirror, at a specific point, at a particular point, there will be a very bright, clear spot appearing on the paper. A very bright, clear spot appearing on the white paper. That means all these rays after reflection will pass through that point. Therefore, all the rays are just getting focused at that point. Thus, the point is very, very bright. That point where your paper is located, that is called focus. That is called focus. Now let us see how to draw the ray diagram for the situation. How to draw the ray diagram for this situation. What did I consider? Here we considered a parallel beam of light rays parallel to the principal axis. Now here this is how it is incident. I will take this point, this ray, the first ray, and here this is the normal. It is making some angle, and thus again the reflected ray should also make the same angle and then pass like this. This is the reflected ray where the angle of incidence is equal to angle of reflection. To our surprise, all the reflected rays pass through this point only. All the reflected rays pass through this point. And what is this point? Practically just now we have discussed about it. This point is called the focus. F. Since all the rays are focusing their light here, the spot appears to be very, very bright but small. If the paper is put here, there will be some bright shade on it, but a little bit bigger. As you are moving away, at this point you can see that it becomes very small, bright and clear, and slowly as you make the paper move far away from this focus point, away from the mirror, we can see that again the size of that broad spot increases, but the brightness of the point or the spot reduces. Why? Because see, if your paper is here, you can see that only two rays are casting their images on this, and that too at different points. So therefore intensity of the spot, that means the brightness of the spot reduces, size of the spot increases as you move the paper either onto this side or this side of it. Okay, so that means when you take the paper away from the mirror, you can see that at a particular point there is a very bright, clear spot. And as you are moving away from, you can see that the brightness reduces and the size of the spot increases. And this particular point is called focal point. This is called focal point. So how to define it? How to define focus? The focus of concave mirror. How to define it? It means when a parallel beam of rays are incident on concave mirror, the point where all the reflected rays pass through, the point from where all the reflected rays pass through is called focus. Is called focus of that concave mirror. Okay, so or you can rather say, if it is not pass through, you can also say that where all the rays converge. Which rays? Rays after reflection. That means the reflected rays converge at a point, and that point is called the focus. In either way you can write the definition. That means when a parallel beam of light rays fall parallel to the principal axis on a concave mirror, the point where all the reflected rays converge is called focal point or focus. Is that clear? Yes. So this is the focus. Now we have learned about another point. Now this is center of curvature, pole of the mirror and focus of this mirror. And the distance between the pole and the focus. The pole and the focus is called focal length. That is called focal length and always represented by small f. Focal length small f, and here the focus is capital F. How are we measuring the distance? From the pole of the mirror. So why I am saying it from the pole of the mirror? In the next classes you will learn it. But try to remember now, you are going to measure the distance of the focus from the mirror, that is from the pole you are measuring it. From the pole of the mirror you are measuring it. That is called focal length F. Is it clear? So now, If this is the case with the concave mirror, how the convex mirror will be? Right? How to locate the focus of a convex mirror. So let us see it now. Convex mirror. So this is the reflecting surface is bulged outwards, and this is the coated surface, or we call it the silvered surface, and this is the convex reflecting surface. Pole of the mirror P, and the center of curvature somewhere here. So a line which passes through center of curvature and pole of the mirror is the principal axis. This is principal axis. As usual, here also normal always passes through the center of the curvature. This is the normal. So principal axis, pole, center of curvature and normal. To find the focus or to locate the focal point, we need rays which are incident on the mirror parallel to the principal axis. So since this is our reflecting surface, from here we consider the rays. So I have taken a beam where there are 4 rays. So here there is no, I didn't consider a ray over here, okay. So we can also take this ray, but you will get confused with whether this is principal axis or ray. Of course there will be a ray along the principal axis also, but here I am not taking that. Alright, so now here what happens? This is the normal, right? With respect to the normal, this is the incident angle. From the first law of reflection as well as second law. First law says that angle of incidence is equal to angle of reflection. Second law says that the reflected ray should lie in the same plane. So it goes back into the same plane. So I think much more wider. Right. So this is what the angle of reflection is. Angle of incidence is equal to angle of reflection. Right. Likewise, you can see that all the rays get diverged away from the point of incidence as if all are coming from a specific point. Let me change the direction properly here. So this is incident here. So this is how my reflected ray should be. And they seem as though that they are coming from here. So I am taking the help of this dotted line to plot the reflection direction. So what is happening here? At this point, the ray is going here, it is going here, and this is going here, and this is going here. You can see that all the rays are getting diverged away. There is no point that they go and converge at a point and form an image. So then how to understand this focus? It is like, if you observe all these reflected rays, they seem as though that they are coming from here. So it should be a straight line. So they appear as though that they are emerging out from this point. All these reflected rays appear as though they are emerging from this particular point. And this point we call it as the focus. And this point is called the focus. This is convex mirror. This is the case with convex mirror. What difference do you find here and here? Here, the reflected rays are converging. The reflected rays are converging. So therefore, this is called convergent mirror. Convergent mirror. And here, the rays after reflection are getting diverged away from. So it is called divergent mirror. Divergent mirror. So convex mirror also called as divergent mirror. Concave mirror also called as convergent mirror. Why? Because the rays, reflected rays here converge and here they diverge. Okay, and since they are diverging, you can't take the image here on a screen. That means like taking a paper or anything, you can't take the image here. So thus, there is a method to plot the focus. What is that? You need to extend the dotted line, right, onto the principal axis, from where they seem to be emerging out. So see, observe here. So what is the direction of this ray? As though it is coming like this. What is the direction of this ray? As though it is coming from here. As though it is coming from here. Here. So thus, from where the rays seem to be emerging out. So that is called focus in case of convergent lens mirror. So how are you going to define focal point of a convex mirror? So when rays parallel to the principal axis are incident on convex mirror, the point from where the reflected rays seem to diverge is called a focal point. They are in fact not getting diverged from here, but they seem to be diverging out from this point, emerging out from this point. So there is a small twist in this definition, that when rays parallel to the principal axis are made to incident on the convex mirror, the point from where the reflected rays seem to emerge is called the focal point or focus of that convex mirror. Is that clear? So here, thus here a real image will be formed. That means image can be captured on a screen. And here a virtual image is formed. That means only the people who will be viewing it can feel as if it is happening or as if the point is here. But it cannot be captured on a screen. So we call that to be a virtual images will be formed in case of convex mirrors, and real images are formed in case of concave mirrors. Okay, this is concave mirror and this is convex mirror. So children, now the task is you have to remember all the points and then you should draw the ray diagrams without violating any principle. Okay, and the next part we can discuss in the next class. Okay, so pause the video for a moment and then you can copy these diagrams, and afterwards you have to practice. And please don't draw freehand diagrams in case of ray optics. Take the help of scale and pencil. Okay.